Hello, students, and welcome to March. I can't believe it's March 1st already. So we'll get started. We have our Do Now, which is a prompt about helping others. Our objective is to continue our work with factoring expressions. And our essential question asks, how do multiplication and division work together when factoring expressions? Remember, to get your participation credit, you've got to complete your Do Now, and that's in Class Notebook. You have a lesson page and your notes, and most important, you have to show your work to the teacher and complete the exit ticket. If you don't get finished in class, you can complete for homework. Also, a good idea to review the lesson that we've done before the next day so you can make sure that you've retained that new information. Important notes, as always, having your camera on shows that you are interested in and participating in the lesson. It helps you to participate and to pay attention better. You earn your participation credit by showing your work to the teacher. Some of you are skipping this all important piece of it. If you don't show me your work, then I don't know that you've done it. If your camera's not working, send an email, but right at the end of the period. Also, while you work, keep the objective and the essential question in mind. That will help you as you learn the new concepts. We will get back to our exit ticket, but for now, we have our Do Now. And March is Disabilities Awareness Month. So, our question today is, how can helping someone who has a disability be beneficial to ourselves? Well, it's easy to understand how it can be beneficial to the other person, but how is it beneficial to ourselves if we help someone else? And have you ever experienced this? And I think for me, that when I help others, it reminds me to be grateful and to be thankful for my own strengths. Maybe I don't appreciate and stop and have a moment of thankfulness for the fact that I can think and learn quickly or walk or other things. And when I help someone who can't do those things as well as I can, it helps me to be grateful and thankful. And being thankful is always a good thing for everybody. So please answer however you'd like right there. And let's get started with our lesson. This is a continuation of yesterday's lesson. So let's get started. So we've got a word problem that involves the inequalities that not inequalities, excuse me, the factoring that we've been doing. So the word problem says a question on a quiz asks students to factor the expression 32m minus 24. Now here's Ryan's answer. He said 4 times the quantity of 8m minus 6, and Jane says 8 times the quantity of 4m minus 3. So who is correct and why? Well, Ryan decided to divide out a 4. So he divided 32 by 4 and got m, and 24 by 4 and got 6. But we still don't have a fully simplified expression here. If we have an 8m minus 6, we can still factor out a 2 to get 4m minus 3. And 4m minus 3 is the fully factored expression when 8 is factored out. So Jane is correct. So when you factor, if you look at the expression in the parentheses and it's still factorable, then you have not finished factoring yet. So Ryan did not factor out the greatest common factor. He factored out a common factor of 4, but there was a larger or greater one. So Ryan did not divide out, because factoring is dividing, the greatest common factor. All right, so let's move on to the rest of the problems we have for today. Now here, we're going to simplify, then factor each expression, okay? If we factor before we simplify, we may not be dividing by the greatest common factor, because when we simplify, we combine like terms. So let's see, we've got 4x minus x, so that would be 3x. And we have negative 2 plus 23, that would be plus 21. Now we can factor, and the greatest common factor of 3 and 21 is 3, so we'll factor out a 3. So 3 divided by 3 is 1, so that's 1x plus 21 divided by 3 is 7. In number 15, we have negative 13 plus 11m minus m plus 5. So first we're going to add up those m's. We have 11 minus 1. We've got an invisible 1 there. So that would be 10m. Negative 13 plus 5 is negative 8. Now we're going to factor the 10 and the 8, and the greatest common factor of 10 and 8 are 2. So we will factor out a 2. 10 divided by 2 is 5. Let's not forget our m term there. 8 divided by 2 is 4. And we have subtraction there, and that's our final answer. Number 16, negative 27 plus 2 plus 23p minus 3p. Okay, so let's see. Let's work with the variable p first. We've got plus 23 minus 3, so that's 20p. And then we have negative 27 plus 2, so that's negative 25. So this is what we're going to factor. And our greatest common factor of 20 and 25 is 5. 20 divided by 5 is 4. There's our variable p. Minus 25 divided by 5 is 5. And 5 times the quantity of 4p minus 5 is our answer. Number 17, we have 7x minus 2y minus 8y plus 11x. Now here, students, we have more than one variable. So we need to be pretty careful when we combine these. X and y cannot be combined. Maybe I should write that down. X and y cannot be combined. Okay, they're not like terms. So let's just look at the x terms. We have 7 minus 8. Whoops, that's a y. See, don't want to make that mistake. We have 7 plus 11. So that's 18x. And then we have negative 2 minus 8. That's negative 10y. Now, we are not going to be able to factor out a variable because we don't have the same variable in both of these terms. So we just look at the 18 and the 10, and the largest number that we can divide out that's common to both of them is a 2. So 18 divided by 2 is 9, and this would be our x term, minus 10 divided by 2 is 5, and that's our y term. And that is our final answer. Now remember, how do we check to make sure that they're correct? We use the distributive property. So let's check. 2 times 9 is 18x minus 5 times 2, 10y. If this matches this, then our answer checks. If it takes us back to where we started, then our answer checks. Okay, number 18. We have 5 times the quantity of 3a minus 2 minus 13a minus 2. Now, we always, if we simplify, we always must distribute before combining like terms. So let's distribute. So 5 times 3 is 15a minus 5 times 2, 10. Then let's just write the rest of the problem, minus 13a minus 2. Now let's combine the A terms. 15 minus 13 is 2. 15 take away 13 is 2, and that's our A term. Negative 10 minus 2 is negative 12. Now let's factor. We've got a 2 and a 12. The greatest common factor is going to be our 2. So 2 divided by 2 is 1. So we have an invisible 1 in front of the A, but we don't write 1A. We just write A. We have our minus 12 times 12 divided by 2 is 6. So 2 times the quantity of A minus 6, and that's our final answer. Now, number 19, something I want you to look at very carefully. We have this negative sign outside of the parentheses 4k minus 17. So a negative sign outside the parentheses changes the signs within the parentheses. So a negative sign outside the parentheses changes the sign inside the parentheses. Okay, so we have to distribute the negative sign through 4k minus 17. So let's rewrite this expression. We have 1 plus 24k. Now, negative 4k, and negative times a negative is a positive, so it's plus 17. Now we will combine the k. 24 minus 4 is 20k, and 1 plus 17 is plus 18. Now the greatest common factor of 20 and 18 is 2. So 20 divided by 2 is 10, and we have our k, plus 18 divided by 2 is 9. And then finally, number 20 and 21. So we will need to distribute the negative 3 through m plus 6n. So we'll start writing our 9m minus 6n. Be careful, we've got two variables here. Negative 3 times this invisible 1 is negative 3m. Negative 3 times positive 6 is negative 18n. Hey, you got all that? If you aren't quite sure, rewind for a few seconds and watch that again. Now, let's combine m's. We have 9 minus 3, so that would be 6m. And then the n's, negative 6 minus 18, that's negative 24n. Now we need to factor out the greatest common factor of 6 and 24. We cannot factor the variable out because we do not have the same variable in both terms. So the greatest common factor of 6 and 24 is a 6. So 6 divided by 6 is 1, so that's an invisible 1, m, minus 24 divided by 6 is 4n. And that's the final answer. And then our last problem of the day, we have to distribute again a negative through a quantity of 6r plus 8s. So let's write this problem with the distribution of the negative. 16r, and remember, you can think of this as a negative 1, if that helps you. So we have 16r plus 2s minus 6r minus 8s, because the negative outside the parentheses changes the sign of everything in parentheses. And then we have our final plus 4r. So we have r and s. I like to put them in alphabetical order. So 16r minus 6r plus 4r Let's see, that's going to be 16 minus 6 is 10 plus 4. That's going to be 14R. Now, plus 2 minus 8 is going to be negative 6S. Now, what is the greatest common factor of 14 and 6? Well, it's going to be 2. 14 divided by 2 is 7R, minus 6 divided by 2 is 3S. And that's a final answer. Now, you can check again by distributing, and I will do that right here. So 2 times 7 is 14R. 2 times negative 3, negative 6S. And this is the same as this. It takes us back to that expression. That means our answer checks. So let's go back up to our exit ticket, which asks, why should we simplify before we factor? We simplify before we factor so that we can determine the greatest common factor of all the terms once they are combined. So we must have all the terms distributed and combined. So we must distribute and combine like terms so we know what we must do to determine the greatest common factor. Okay, because if we don't know accurately what our numbers are, we won't know what we divide by. So that's our lesson for today. Thank you for working hard. Thank you for all the work you do in our math class. It's a joy to be with you. Hopefully soon we can all be in class together, not just watching videos. But I thank you for your hard work, and I know that you are practicing, and I know that you know as you continue to practice, you'll be great.